Pere, 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 pere. Pere, 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 pere. Pere, 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 pere. Gotcha.
What's up mga kairek? And for today's video, we are assigned to solve two problems with different topics. So for the first problem, it's all about thermal stress. So short info about thermal stress. So when the temperature of materials is raised or lowered and the body of materials is not permitted or not allowable to expand or contract freely, it is in the state of thermal stress. So now, here is the problem for the thermal stress. A 5-meter long bronze bar with a cross-sectional area of 350 mm is placed between two rigid walls as shown in the figure at a temperature of -20 degrees. The gap is 25 mm. Find the temperature at which the compressive stress in the bar will be 40 MPa. Use coefficient of linear expansion 18.0 times 10 raised to 6 meter/meter degree Celsius and modulus elasticity of 80 gigapascal. So, first thing you need to do when solving a problem is to write down the given. So, length is 5 meters and the gap is 25 millimeters. So, convertin natin siya to meters kasi ito yung gagamitin natin sa pag-solve natin mamaya. Then, modulus elasticity is equals to, convert na rin natin siya sa Newton meter squared, and the initial temperature is -20 degrees Celsius. Then, for the coefficient and for the compressive stress is 40 megapascal. Convert na rin natin siya to Newton meter squared. Then, the coefficient of linear expansion is 8. Write down na rin natin. So, based dito sa problem, ang required natin is the final temperature. Dito, meron itong figure 1 and figure 2. So, now, we'll go on the solution. So, to get the final temperature, we need to first to get the change in temperature, which is equals to final temperature minus initial temperature. But to get the initial change in temperature, we need to get the deformation due to change in temperature, which is equals to the gap plus actual deformation. So, based dito sa figure, makikita naman natin yung kung alin yung ano natin dito, yung sa change in deformation due to change in temperature and actual deformation. So, yun na nga, but deformation due to change in temperature is equals to A times length times change in temperature. Kasi kitang-kita naman doon sa figure kung bakit yan yung. Then, the actual deformation is equals to compressive stress times length times E. So, substitute na lang natin guys. So, A times length times change in temperature is equals to gap plus compressive stress times length over modulus elasticity. So, since dito sa formula lang ito, nandito naman lahat sa given, substitute na lang natin siya guys. So, the 18.0 times times 10 raised to negative 6 m over m degrees Celsius 100 degrees Celsius times 5 meters, and then change in temperature is equals to 0.025 meters plus 40 times 10 raised to 6 Newton over meter squared times 5 meter over modulus elasticity natin is 80 times 10 raised to 9 Newton meter squared. Now, kuha lang muna tayo ng calculator para i-solve to. So, now, compute na lang natin muna siya sa calculator. Right down. So, para mas mapadali ang pag-solve natin, unahin muna natin to sa compressive stress times length over modulus elasticity. So, 9 times 10 raised to negative 5 meter over degrees Celsius times change in temperature. Write down muna natin to. Yung gap 0.025 meters plus, so solve ulit natin to. Maka-cancel, ang magiging unit nito is meters na lang kasi cancel yung Newton, tapos yung meter cube, tapos meter squared. So, plus 0.0025 meters. Now, add na lang natin itong dalawang to since same lang naman yung unit nila. So, write down ulit natin itong 9 times 10 is negative 5 meter over degree Celsius. Change in temperature is equals to 0.0275 meter. So, since same lang naman tong problem, same lang yung unit, so pwede natin siyang i-add. Pero kung magkaiba yan, so bawal. So, transpose na lang natin para mas makuha natin yung change in temperature. So, 0.0275 meters over 9 times 10 raised to negative 5 tapos meter over degree Celsius. Cancel natin yung meter para maging Celsius na lang yung unit ng ating change in temperature. Since temperature yung hinahanap natin, kailangan yung unit is naka degree Celsius or Fahrenheit. Since degree Celsius yung dito, ito yung gagamitin natin. Solve muna tayo. So, yung change in temperature natin is equals to 305.56 degree Celsius. Now, since kuha na natin yung change in temperature, balik na tayo dito sa una natin formula para makuha yung final temperature. So, yung temperature is equals to final temperature minus Ti Then, final temperature is equals to change in temperature minus initial temperature. So, substitute lang natin siya, guys. So, 305.6 degrees Celsius plus negative 20 degrees Celsius. So, labas na lang natin siya sa parenthesis. So, magiging minus 20 degrees Celsius. And makakuha natin is final temperature is 285.5 degree Celsius. So, yun na nga. So, for the problem number 1, ang answer natin is 285.5 degrees Celsius. And now for the second problem, for the topic torsion. So, little information about torsion. So, the twisting of an object due to an applied torque, or another example is another meaning is suppose a circular is rigidly attached to the wall at one end and twisted at the other end by a torque or twisting moment, which is applied perpendicular to the axis of the bar. Given that scenario, the bar is said to be in torsion. For the problem for torsion, determine the maximum torque that can be applied to a hollow circular steel shaft having an outside diameter of 100 millimeters and an inside diameter of 80 millimeters, without exceeding a shearing stress of 60 megapascal or a twist of 0.5 degree over meter. Use the modulus of rigidity 83 gigapascal. Now, the first thing we need to do to solve this problem is to write down the given. So, let's start with outside diameter is equals to 100 millimeters. Convert na rin natin siya to meters since ito yung gagamitin natin mamaya sa pag-solve. 0.10 meters. Then, inside diameter is equals to 80 millimeters equals to or 0.08 meters. Then, for the maximum shearing stress is equals to 60 megapascal. Convert na rin natin siya to Newton over meter squared kasi ito yung gagamitin natin pag solve mamaya. 60 times 10 meters squared. Now, 0.5 degree over meters. Then, yung modulus of rigidity natin is 83 gigapascal. Then, lagay na rin natin itong nasa problem, itong hollow circular steel shaft. Then, convertan natin pala itong G natin to Newton over meter squared. So, 83 times 10 raised to 9. Dito na tayo sa required. Ang required natin is maximum torque. Maximum torque. Like now, sa solution, based dito sa figure, ang gagamitin natin na formula para sa Dalawa ang gagamitin natin dito yung solution is based on allowable shearing stress and based on allowable angle of twist. So, unahin natin itong based on maximum allowable shearing stress. And based dito naman sa ating figure na hollow circular steel shaft, ang gagamitin natin para sa shearing stress is equals to 16/3 outside diameter over pi times outer diameter raised to 4 minus inside diameter raised to 4. So, ito yung ginamit nating formula kasi hollow, yung nasa problem natin sa hollow circular, magkaiba yung hollow circular sa solid circular. So, based naman dito sa figure natin, halatang-halata naman. Then, dito sa formula natin is nandito na lahat sa given natin, substitute na lang natin para makuha natin yung value ng T. Kasi yun ang hinahanap natin. So, yung maximum shearing stress is 60 times 10 raised to 6 Newton over meter squared equals 16 times T times 0.10 meters over pi times 0.10 meter raised to 4, tapos inside diameter natin is 0.08 meter raised to 4. So, para mapadali guys yung pag-solve natin dito, pwede natin tong i-transpose para maiwan na lang yung T dito, para isahan na lang yung pag-compute nyo sa calculator, mas mapapadali kaysa mag-part by part tayo. So, T is equals to 60 times 10 raised to 6 Newton over meter squared times pi times 0.10 meter cube raised to 4 minus 0.08 meter raised to 4, so over 16 times 0.10 meter. So, ganda ng calculator kasi mahaba-haba ito, pero at least isaahan na lang. 60 times 10 raised to 6 times pi times 0.10 raised to 4 minus 0. Over. Then, ang unit ng torque natin or yung twisting moment is Newton meter. So, T is equals to 6,955.5 Newton meter. So, ito yung nakuha nating torque based on allowable shearing stress. So, next, solve na rin natin yung based on maximum allowable angle of twist. So, base dito sa given, dalawa yung solve natin para malaman kung alin yung dapat na gamitin. So, ang formula natin dito is angle of twist is equals to torque times length over polar moment of inertia times modulus of rigidity. So, yung J natin is ang polar moment of inertia natin is ang unit niyan is raised to 4, meter raised to 4. So, solve muna natin yung J natin. So, J is equals to pi over 32 times outside diameter raised to 4 minus inside diameter raised to 4. So, yan ang formula na gagamitin natin para makuha yung polar moment of inertia. So, since nandito naman lahat sa given yung value nito, J is equals to pi over 32 times. Ito yung formula natin sa polar moment of inertia for hollow shaft. So, 0.10 raised to 4 is 0.08 meter raised to 4. So, calculate na lang muna natin. So, J is equals to 5.80 times 10 raised to negative 6 meter raised to 4. So, since nakuha na natin yung J, pwede na tayong bumalik dito sa una natin formula para makuha na natin yung maximum allowable angle of twist. Okay. Yung torque based on maximum allowable angle of twist. So, substitute na lang natin, guys. So, balik tayo sa formula. So, substitute na natin. 0.5 degree over meter. So, since radian ang kailangan natin dito, i-convert natin siya. So, using pi over 180 degree para makuha natin yung unit na radian, equals T. T is torque or twisting moment. Yun ang hinahanap natin dito sa problem na to. So, T over, so, lagyan na natin yung polar moment of inertia na nakuha natin. So, 5.80 times 10 raised to 6 Newton meter. Sorry. Okay. Kailangan meter raised to 4. Times yung ating modulus of rigidity, 83 times 10 raised to 9 Newton meter squared. Newton over meter squared. Sorry, palagi nagkakamali dyan. So, para isahan na rin naman ang pag-compute natin ito, pwede na natin itong i-transpose para maiwan lang naman ulit yung T natin. Then, mas mapapadali ang pag-compute natin. So, T is equals to 0.5 degree over meter times pi times 180 degree. Tandaan na pag torque, ang unit natin dito is Newton meter. So, cancel na lang naman to. So, 5.80 times 10 minus 6 meter raised to 4 times 83 times 10 raised to 9 Newton over meter squared. So, compute po natin gamit ng calculator. So, T natin is equals to medyo mahaba ang pag-type nito, pero at least isa na lang yung pag-compute natin. And acceptable naman ito. So, yung T natin is equals to 4,201.008 Newton meter. So, yun na guys. Nakuha na natin yung dalawang value ng torque using two solutions. So, based on maximum allowable shearing stress and based on maximum allowable angle of twist. So, always remember na pag sa torsion, always use smaller torque. Kasi, ang purpose natin dito is to lessen the stress na marireceive ng materials. Kasi, kung gagamitin natin dito yung mas mataas na torque, lalampas na siya dun sa maximum allowable stress na nung hollow circular steel shaft natin. Kaya ang mas pipiliin natin is yung mas maliit, yung smaller torque, para mas maliit yung stress din na makuha nung circular steel shaft natin. Kasi yun yung purpose talaga ng pag-ano natin. Kaya inaalam natin yung twisting moment ng materials. So,
Pere. Gotcha.
so that's for all today's problem about one problem for thermal stress and one problem for torsion. Hope you understand this lesson for today, and you understand about how to solve the given problem. If you have any question, just comment down below so I can reply to you anytime, and hope you like it. Thanks for watching.